All right, so one exercise which we have touched on, the wording here isn't particularly useful, but we'll go through it with what we already know and then it'll make it a little bit easier for you. So the remainder theorem, we've already looked at the factor theorem. If I substitute a number into the polynomial and that makes the polynomial equal 0, then x minus whatever number I subbed in is a factor of that polynomial. And we've been using that to factorize cubics and sketch cubics and do all those sorts of things. The remainder theorem is a more general case of the factor theorem. The remainder theorem says if I substitute a number into the polynomial and the answer is not 0, what that answer is actually the remainder when I divide the polynomial by the factor that I substituted in. Now, the way they've worded it here is a little bit tricky when p of x is divided by beta x minus alpha. So that's just saying it's a linear factor. And they've used beta and alpha because they're getting excited about that. I don't know why they use beta and alpha. We could have just gone ax plus b. It doesn't really matter. When it's divided by some sort of constant times x plus a number, so a linear factor, what we need to do is substitute in negative alpha over beta. Why are they doing that? I've tried to explain it in words that I think make a little bit more sense over here on the right. If you divide by a linear factor, the remainder can be found by substituting in the 0, the root, or the x-intercept of the linear factor. So usually we've been doing x minus 4. If I want to find the remainder from that, I substitute in 4 because 4 is what makes that bracket 0. Well, when you've got more complicated brackets, the same thing applies. So if my linear factor was 2x minus 3, if I wanted to find the remainder when I divide by 2x minus 3, what do I need to substitute in? 3 over 2. Now, the easy way to do that, if I just factorize the 2 out of that bracket, oh, my brain's going faster than my pen. X minus 3 over 2. You can see they're equivalent, correct? So now you can see if I substituted in 3 over 2, that would be making it equal to 0. So although it looks confusing and the wording's a bit strange, it's really straightforward and pretty much the same thing. So we're just going to do a couple of examples. Find the remainder R by long division and by the remainder theorem. Well, I know you guys know how to do long division, so let's not waste our time doing that. Let's focus on the remainder theorem. If I'm dividing by x plus 4, remember you think in your head that's the same as x minus negative 4. So I can substitute negative 4 into the expression and I'll get my answer. So give yourselves a few seconds to do that. Four, 16, 64, 256 by 2, that's 512. What's that? 280 and 60, 340. So 172. Someone better check my calculations on that. That's the remainder. So it's a lot nicer than going through long division and finding those big numbers in my division. That would be difficult. There's one for you to try there. Again, this division would be a little bit more complicated because you have to add in that extra term, wouldn't you? The plus 0x that's missing. In this case, we don't need to do anything. If I want to find the remainder when I'm dividing by x minus 3, what number do I substitute in? 3. Did you guys check my working on the other one? No one confirmed it for me. Okay, thank you. As long as someone did, I'm happy. I gave you a head start. We should be nearly there. I'll pause for another 20 seconds. There you go. Oh, that's time. 3, 9, 27, minus 9 fours are 36, plus 9. Wow, the remainder equals 0. That tells us what about x minus 3? Oh, you guys are geniuses. Two more examples to do. We've still got a bit over 10 minutes, so we've got plenty of time. Have a go at question B there. X cubed minus 2x plus 4 is divided by 2x plus 1. Now, you can either remember the rule from up the top, negative alpha over beta. I'm going to forget that rule. I don't, because why would they putting beta before alpha? I'm going to forget that. What do I just think about? What's another way of writing that linear factor? All right, from there, I'm sure you know what to substitute in to get your answer. I'll give you a minute. All right, we've found what we had to do. So what do we have to substitute in? Negative a half. So the remainder is going to be P. This time they've defined P of x for us, which is much easier. Substitute in negative 1/2. So I'm going to have negative 1/2 cubed minus 2 times negative 1/2 plus 4, negative 1/8 plus 1 plus 4, 5 minus 1/8, 39 over 8. And if we zoom in, you can see that they agree with us. Isn't that nice? Go you, go us. Last one, a fun exam style question, because it's just making you work a little bit backwards. The good news is this would probably come as a complex familiar question. Complex familiar, that's giveaway marks. We would ask you harder than that in grade 10, wouldn't we? So you're going to be able to do this okay. P of x equals x cubed plus 2x plus 8. It's divided by x minus 2, and the remainder is 4. Find the value of a. Do not do division. You can get there doing division, but use your remainder theorem. It's going to make more sense. I'll give you a couple of minutes to have a crack. If you need some help, put your hand up, but I think you guys are going to be fine. But communication is nice and important in your working, particularly for an external exam. So when P of x is divided by x minus 2, the remainder is 4. That implies P of 2 is equal to 4. And you could even say by the remainder theorem if you really wanted to. So what's that equivalent to now? P of 2, well, that's 2 cubed plus 2 by 2 plus a equals 4. 8 and 4 make 12 plus a equals 4. Therefore, a equals negative 8. And you're done. So as I said, probably complex familiar, but 3 marks. Take them. Give away marks. You did that in well under 3 minutes. You know you're going to be cruising. The rest of the exercise is just like that. I know you've done this stuff before. There are some questions there for you to try in the last couple of minutes. Other than that, keep up your great work. That's term 1. Done. Celebrate. I can't believe there was so little celebration of that.